Hello and welcome back to Higher Maths Integration. Remember, what on earth is integration? Integration undoes differentiation. It is anti-differentiation. Why do we use it? We normally use it to find the area between a curve and the x-axis. We've not got as far through the topic as looking at that yet, but that's why we do it, in case you're wondering why on earth we do it. That is why we do it. So let's have a look at question 6 here. So similar to question 5, but slightly more difficult. So differentiate y equals. So again, we're going to have to use a chain rule for part A there to differentiate, and part B, hence find the integral of that. So without part A, we do not have the mathematical knowledge to integrate part B on its own. But because it says hence there, that's saying using what we've got in part A, we will be able to do it. So part B on its own is basically an advanced higher question. But with part A there, we are able to integrate that because we know that integration undoes differentiation. That is the knowledge we are going to use to do this question. So part A, bracket to the negative 5. So dy dx equals negative 5 bracket to the negative 6 multiplied by the derivative of the bracket. So if we differentiate this bracket, we get 3x squared. So that'll be negative 5 multiplied by 3x squared, so negative 15x squared. And it's bracket to the negative 6. We'll move that down to the denominator, negative 15x squared over bracket to the power 6. Okay. So part B, hence find. So I'm looking at this. This looks very, very much like that, except it's negative 15 times as large. Okay. So part B, find the integral of this. So if I integrate my answer to part A, which I don't know how to do using my higher maths knowledge, if I integrate that, because I know integration undoes differentiation, I know I will get back to that. I will get back to what I was asked to differentiate in part A. Okay, if I integrate this without any working, I will get back to 1 over bracket to the 5. Because I know integration undoes differentiation. Okay. So if I'm just integrating x squared over bracket to the 6, if I write minus 15 or negative 15 at the front there, if I'll integrate this and get back to what I was asked to differentiate in part A, but I can't just put a minus 15 there. I'll need to take out a negative 1/15, because when I multiply this by negative 15, I will get 1, because it's 1x squared at the moment. Okay. So integrate all of this. Oh dear, I've not put dx there. That's very bad. There should definitely be a dx there, because I've not integrated yet. So that'll be negative 1/15 of 1 over bracket to the 5. So just multiply through. So negative 1 multiplied by 1, negative 1 over 15 bracket to the 5. Okay. Again, if I integrate everything here, I will get this, because integration undoes differentiation. So negative 1/15 multiplied by negative 15 is 1, which is what I'm being asked to integrate. So I'm using my answer to part A to enable me to integrate in part B.